To share the new Web Explorer for the data that we shared in our Climate Champions Design Summit, and you can use with your students to explore heat across our county and the broader world. So, in our Climate Champions Design Summit, we explored the idea of land surface temperatures, and this is just a friendly reminder about land surface temperatures and where the image comes from and where this data is coming from. And this is an excerpt from the work by the research team as part of the SoCal Heat Hub that developed this Web Explorer. And there's a more in-depth explanation of these data sets and the Web Explorer that is linked to this video. So, of course, there's a couple types of sensing from satellites. We have active sensors that use an internal source of energy to send pulses of laser radar to the Earth's surface and detect the energy reflected back to its sensor. And good examples of this are LiDAR. What we're going to be looking at with land surface temperatures and NDVI is passive sensing. So passive sensors use an external source of energy, otherwise known as our sun, and can measure the energy that is reflected or radiated from the Earth's surface. It's an energy from another source, and the most common source of radiation is reflected and re-radiated heat from our sun. Other sources, of course, are things like emitted light from things like lights at night. And this is the type of data that we're using to generate the land surface temperature data that we'll be looking at. So let's talk a little bit about re-radiation of heat. So for our sun, it primarily gives off shortwave radiation, and that's the solar radiation from our sun. And then that energy, which is absorbed and then re-radiated, is re-radiated as long wave radiation. Of course, the difference, as you can see in this figure, is in wavelength of that electromagnetic radiation. So, as we look at this figure right here that is excerpted from NASA, you can see that there's incoming shortwave radiation on the right. And let me turn on my pointer so that I can highlight this. So the solar radiation that comes in gets absorbed and or reflected. I want to emphasize that if it is reflected, it is reflected shortwave radiation, not long wave radiation. And of course, that reflection can happen through clouds as well. Re-radiation is where the short wave gets absorbed and then re-radiated as a different wavelength, and that would be long wave. So this is the important distinction, is that as solar radiation comes in, it gets absorbed or reflected, and then if it's absorbed, it re-radiates back as long wave radiation. And that's the distinction between reflected solar radiation and emitted long wave radiation. So land surface temperatures are data that are derived from satellite measurements of re-radiated, not reflected energy from our sun. So the wavelength of that energy is dependent upon the temperature of the Earth's surface at any given location. And that's how we get these land surface temperature maps. We shared this data in a Google Drive folder, and what we had to do for the data is we had to create screenshots of different locations of different schools and different parts of San Diego. But now we have a Web Explorer where we can type in any location anywhere, and not only can we get it for land surface temperatures, we can also get it for greenness. And we talked about that at our climate summit as well, which is a measurement called NDVI. So going back to this tool, this is called the Ecohydrology and Heat Explorer. If you work at a school, for example, like Del Lago Academy in Escondido, you can type the name of the school and it'll send you right to that location. And then what you'll see is that you've got a slider so that you can view two layers, so that you can do a comparison between either different years, different seasons, and then different data sets. So let's take a look at land surface temperatures and land surface temperatures with the data that we shared in our Climate Champions Design Summit were in the summertime. That's where there's the greatest differences. And I can compare 2015 to 2021. I'm going to do that right now. Summer, and right now we're looking at Del Lago Academy. And then what I can do is I can zoom out a bit. And as I zoom out, what it'll load is on the left side, the data from 2015. On the right side, it'll load the data from 2021. Now, the important thing to note is that it takes a little while to load. So how you use this with students, you want to be strategic because you might end up with students that are a little impatient for the data to load to be able to answer their questions that they have. So a strategy that we recommend is screenshotting and exporting the data that you want students to look at. So I'm going to use this slider and drag back and forth, and you can see that there's a subtle difference. And that subtle difference, you might notice right away, is that 2021 was a little bit cooler than 2015. But say I want to know with a little greater degree of precision, or I want to look in one particular location. I'm going to pick this location. I'm just going to click a dot, and when I select, you want to be patient. So I've clicked on the map, and what will load are some figures that are for that point that I've selected. So again, the point I've selected is down on the map where you see right where my cursor is moving, and hopefully it'll load in a second. And again, this is why we want to be patient. Now, while it's loading, I'm going to show off that you have all this additional information about the data sets on the left. If you have questions about what NDVI is, how it's being captured, and same for land surface temperatures. So now you can see that the point that I selected is now loading. And on the left, this is for the 2015 summer LST, and on the right, it's the 2021 summer LST. You might get a page unresponsive, just click wait, be patient, it will generate some figures in just a moment. So as it's loading those figures, what you'll see is that you'll get a time series over the summer. So I'm going to actually click this button, and this is actually showing the time series for NDVI for that point that I selected. And then this is NDVI over time for 2021. You'll have the measurement of the average land surface temperature for that red dot now that you see on the map. And then same for NDVI over here as well. So you can do the comparison between two different times. You can do two different seasons. You can even compare and start to load, although it'll take quite a while. I just selected NDVI, and now I just want to compare NDVI 2021 to LST 2021. And you'll see on the left, it'll load land surface temperature, and then on the right, it'll load NDVI. So that gives you a sense of like how long it takes to load. And like I said, you can use screenshots and you can click and you can access these figures and the data. And you can even have students do it, of course. We recommend they do it. But just know that it takes some time. You will also have the capability of drawing a polygon and selecting instead of a single point an area. So that's another thing to pay attention to, is that you'll have the ability to draw a location, and you have the polygon drawing tools right up here to be able to select your location or select how you want to select that area. Like I'll select this area, and then the data will load for that polygon that was drawn. If you have any questions, I'm going to put the links to the feedback form for this web explorer, and you can submit your feedback and ask questions related to this web application. Thank you.